What is carbon-14 and how does it help us? Carbon has an atomic number of 6, standard atomic weight of 12.011, and is a polyatomic nonmetal. Atoms have a nucleus with both protons and neutrons. Shells outside the nucleus have electrons. Atoms with the same number of protons, but varying values of neutrons, are isotopes of one element. The atomic mass, sum of neutrons and protons, is different, but the atomic number, number of protons, is the same. It's a chemical element with an atomic number of 6. It has many uses, including ensuring that without forming adverse byproducts, potential drugs can be metabolized. Carbon-14 dating, or radiocarbon dating, is the largest use, allowing scientists to date when organisms died in the past. Very useful because it helps give historians and scientists a better view of past animals and humans. Carbon has 3 natural isotopes but 15 overall. The natural isotopes are carbon-12, carbon-13, and carbon-14. Carbon-12 is the most common, while carbon-12 is by far the least common. As shown in the diagram, carbon-14 has 6 protons, 6 electrons, meaning this specific atom has a neutral charge, and 8 neutrons, making it unstable. Carbon-14 is unstable, unlike carbon-12 and carbon-13, which are stable as shown on the map of nuclide. Carbon-14 goes through negative beta decay, which is enforced by the weak force. The negative beta decay turns a neutron into a proton to make it stable. The unstable nucleus emits radiation as an energetic electron and an antineutrino. Carbon-14 undergoes nuclear transmutation because it becomes a new element, nitrogen-14, with 7 protons. Nitrogen-14 is stable. The atomic number changes, but the atomic mass does not. Carbon-14 is the parent nuclide, and the daughter nuclide is nitrogen-14. Carbon-14 has a half-life of 5,730 years, plus or minus 40 years, meaning around every 5,730 years, only half of the carbon-14 atoms are left in the sample, so there is a 50% chance that a carbon-14 atom has decayed after the half-life time. An energetic neutron that results from a cosmic ray collision with an atom bombards a nitrogen-14 atom, turning it into a carbon-14 atom and a free proton. It exists in all living things because it later becomes part of carbon dioxide. Plants then take in the carbon dioxide, and the other living things eat the plants, providing it. How is it measured? Part of the sample is burned into carbon dioxide and passed through a sterile vacuum system with purifying methods. An instrument records how many carbon-14 atoms decay in a vacuum per minute per second, and then compared to the amount of carbon-12 atoms in the sample to see how much of it is decayed. This ratio can be used by algebraically solving the bolded equation for the number of half-lives that have passed since its death, n. Knowing the half-life, we can then use the number of half-lives that occurred to tell us how many years have passed since their death. The ratio between carbon-12 and carbon-14 is the same in all living things. It depends on the amount of carbon-14 in the atmosphere at that time. The scientists calculate the amount in the atmosphere by analyzing tree rings and speleothems to determine how much carbon-14 was in the atmosphere at a certain time in history. How effective? It only works on dead samples. After about 50,000 years, the percentage of carbon-14 is gone due to the relatively short half-life. Carbon-14 dating is used by geologists, archaeologists, geophysicists, and other branches of science. Historians also use it to get a better idea of the past. How effective? Part 2. C14 dating does not work well in samples older than 20,000 years due to low C14 levels and under 30 years because the degree of error is larger than the result. A standard deviation is needed because the date is not perfect and depends on human, random, and systematic error. There have been extremely off cases, but they can be explained. Side effects. C14 gives a whole-body radiation dose that is 1% the dose rate caused by natural background radiation. According to Robert O. Pohl's 1976 journal, it causes deaths due to cancer from radiation and other negative health effects. Others disagree and claim that it has little to no effect on humans because the half-life is large compared to human life, the dose rate is so low, and there are other stronger natural causes of cancer. Some people even think it is a source of radiological hormesis, which is a hypothesis that low doses of radiation actually help prevent disease by activating mechanisms in the body that fight it. Social factor. C14 dating has sparked heavy debate regarding religion and science. People have tried to disprove young Earth creationists who believe that the universe was formed between 5,700 years ago and 10,000 years ago using carbon dating. Others have attempted to find problems with C14 dating and actually use it to try and prove their own beliefs using such as the Great Flood. The debate sparked many websites such as Answering Genesis and the Secular Web, which both use carbon-14 dating to affirm their own separate beliefs, also leading to film debates and separation in society due to strong beliefs. Additionally, the method has possibly disproved many popular beliefs in history, like the Shroud of Turin, which was supposed to be from Jesus' death, but was actually tested to be from the 14th century. Examples like this cause controversies and have changed certain cultures' histories, having a profound effect on the people in those cultures. Despite these controversies, I think carbon-14 dating is worth it. The scientific discoveries and newly acquired knowledge of the past, present, and discoveries for the future far outweigh disputes about the past. It also solves some disputes because it provides evidence to disprove or support claims that do not rely heavily on myths or assumptions, especially in history.